Welcome to Easy Elim Learning Simplified. My name is Ruth, and today we are going to be looking at the topic structure of the atom and the periodic table. Our subtopic for today is still on writing formulas, but now we are going to form formulas purely from radicals or polyatomic ions. Previously, we talked about forming formula from the monoatomic ions from the 20 elements and also the transitional elements with radicals or polyatomic ions, so you can check that out. So for this lesson, we will purely make it using radicals, and then we will get a chance to practice. So just reminding ourselves. So today we are going to look at these radicals, but now we are going to be using ammonium ion as the cation. And you can see in our radicals, it's the only positive cation. All the other radicals or polyatomic ions are negatively charged. So basically, we're just going to see the reaction of ammonium ions with all of this so that you can see how that reaction occurs. So remember how we write these formulas for these radicals as we move on. So looking at the procedure, it's the same procedure. We will list the cation and an ion. So in this case, our cation will be the ammonium ion, and the anion will be any other radical that is negatively charged. And then we are going to get their valencies. We know that the valency of ammonium is 1. The other radicals are the ones that are negatively charged have different valencies. And then we will put brackets around the both polyatomic ions, both on the ammonium ion and the other ones. And then you crisscross the valencies and cancel where it's possible. And if it can't be cancelled, we are going to leave it out. So let's do an example so that you can understand what I just said. So first of all, let's look at ammonium nitrate. So ammonium is written like this with valency 1. We say the first thing, you put a bracket. Whenever you have a polyatomic, always put a bracket so that you don't end up like touching anything on the polyatomic. It comes as a whole. That's why we keep on putting it in a bracket. And then nitrate is written as NO3 and also has a valency of 1. You can see I put it in a bracket. Then after that, I crisscross the valencies. When I crisscross the valencies, I want still to retain the brackets until the end. So it becomes then 1, that 1 comes here, and then nitrate, this 1 becomes here. So we said whenever you have 1 outside the bracket, you have no reason to put the bracket on. So you open the bracket, it becomes ammonium and then nitrate. So this is how it's written. All right, so let's look at another example, ammonium hydroxide. So once again, ammonium has a valency of 1. Remember, we put it in a bracket, and then hydroxide has a valency of 1. Some of these ammonium salts do not exist, but we are using them for this purpose so that you can be able to understand how to write the formulas. It does not necessarily mean they exist. Some of them, they do not exist in nature. So ammonium hydroxide, so we crisscross the valencies. Let's crisscross. So this becomes 1 and hydroxide 1. The moment you realize this, there's a 1 outside this bracket, you don't have to put it, there's a 1 outside this bracket. So our final answer becomes ammonium hydroxide. This becomes our answer. So next, we are going to look at ammonium hydrogen carbonate. So let's get rid of this. So first of all, we start with ammonium, valence is 1, and then hydrogen carbonate is written like this. It's a polyatomic ion with a negative 1, so the valence is 1. So we crisscross the valences. So ammonium picks the 1 from the hydrogen carbonate, and then the hydrogen carbonate picks the 1 from ammonia. So we don't have to put the brackets when there's just 1 outside the bracket, so it becomes ammonium hydrogen carbonate. This becomes our answer. Let's look at one final example, ammonium hydrogen sulfate. So let's wrap this So ammonium is NH, then valency is 1. We put it in a bracket. Then hydrogen sulfate is written like that with also a valency of 1. We crisscross the valencies. So it becomes ammonium with a valency of 1 outside and hydrogen sulfate, the 1. When you notice this, we said you do not need to put a bracket. So it becomes ammonium hydrogen sulfate. And that brings us to the end. So next we are going to look at the ones now that cannot cancel out like those ones, how they cancel out very well. So first you start with ammonium sulfate. So ammonium, once again, valence is 1. Remember we put it in a bracket. And then sulfate, it's an 8. So it's 4 with a valency 2. You crisscross the valencies. You get ammonium but in bracket 2, and then sulfate, but in bracket 1. So this, for the ammonium, you retain the bracket, so the answer becomes ammonium 2. But for the sulfate, we don't have to put the bracket because there's one outside, so this becomes the answer. Let's look at ammonium sulfite, now with an ITE. So ammonium valency is 1. Then sulfite now with 3 becomes 2. We crisscross the valencies. So we have ammonium still in bracket with a 2 and the sulfate with a 1. So this becomes, remember there's a 2 outside the ammonium, so it's going to be retained. So it becomes 2, but there's a 1 outside, so you just remove the bracket and this is our final answer. Next, we look at ammonium carbonate. So the ammonium valence is 1, carbonate valence is 2. So you crisscross the charges. So on the ammonium, we put the 2, and carbonate, we put the 1. So this one, the ammonium bracket is going to be retained, so it becomes ammonium 2, and the carbonate we remove because it's a 1. And then we have ammonium phosphate. So ammonium valency is 1, phosphate, which valency is 3. So you crisscross the valencies, you get ammonium with 3 and phosphate with a 1. So the bracket on ammonium is retained, so it becomes ammonium phosphate. The bracket on the phosphate is removed. This becomes your answer. So that brings us to the end of forming the formulas. But now, how do we name from the already formed formulas? So this is ammonium sulfate. This is ammonium hydroxide. This is ammonium nitrate. This is ammonium phosphate. Then next, we are going to be counting the number of atoms in the compound. You said this is important when we get to balancing equations. So for this one, we remember the number of nitrogen is only 1 inside the bracket. So when we open the bracket, this 2 multiplies to this 1 to form 2 atoms of nitrogen. And then it also multiplies with the 4 atoms of hydrogen to form 8. You open that bracket. Sulfur, there's 1 here, so it's 1. And oxygen, it's 4, as you can see. Ammonium hydroxide, the nitrogen here, it's only 1 atom. Hydrogen is 4, as you can see. Oxygen is 1. And hydrogen is also 1, as you can see. For ammonium nitrate, the nitrogen is 1. There's no bracket in this case. Hydrogen is 4, as you can see. Nitrogen, there's another 1 here. And oxygen, there are 3. So you can see the total number of nitrogens are actually 2 because there is 1 here and 1 here. So it's important you understand where the 2 nitrogens come from. This is one of the compounds that can be a bit tricky when we are balancing, so you need to remember that. And then we have ammonium phosphate. Remember there's a 1 inside here, so these 3 will multiply by this 1. So we have 3 atoms of nitrogen, and then these 3 also multiply this 4. So we have 12 atoms of hydrogen. Phosphorus, you can see it's 1, and oxygen is 4. So that brings us to the end. I'll see you in the next session.